passed, so I'm going to get started. So welcome to the BCS Special Interest Group in Software Testing special event on testing contact tracing. So the background to this event is that Dermot, the technical test lead for the MIT Safe Places project, made an ask for help from the testing community on Twitter about 3 weeks ago, asking for help with testing a contact tracing solution. This immediately caught my eye because I've always been keen on open source and contributing to open source projects through testing, but also because the BCS law specialist group did a deep dive a few weeks ago into contact tracing that was very interesting and got me a bit worried and fired up some concerns that I had about proprietary closed solutions and the long-term implications of us trading one type of liberty for another type of liberty. And what's important to me about open source in this context is the absolute transparency and ability to be scrutinized. Before I did anything on this project, I spent Saturday looking into it, getting up to speed with the tech, the goals, and what the testing challenges actually were. Then reached out to a few members of this special interest group to see if they wanted to help, and was quickly joined by Jonathan Wright, who will be speaking later on the Sunday, who started looking at testing in production. Just because open source is open to scrutiny, it doesn't mean it's secure, private, or of any higher quality than any other software and systems. So testing is essential to ensure that it does what it says on the tin. Organizing testing in an open source manner is not easy at all. So we'll be talking to Dermot about that later on, and also what extra help the project might need. First, though, we're going to get an implementation overview from an overview of the project from Khalil from the SafePass implementation team. Then I'm going to give a quick demo of the end-to-end solution. And then we'll have Francesco from Primal, who's going to talk about he helped with one of our test data challenges. And then we'll go to Jonathan Wright. And then to Dermot to talk more about the test. Quite a few testing companies have contributed tool licenses and resources along the way, and I'm sure we'll give some shout outs to them as we go along. We are getting some echo. I'm not sure why that is. So elsewhere in BCS, the law group is having a study group session tomorrow night to look at the technical guidance from the EU's Data Protection Board. And fresh off the press, BCS has prepared a policy paper on contact tracing, which was circulated today to a select group. While it's not publicly available, I'm sure there'll be a press release out about that soon. You may also be aware BCS is running a Vital Workers campaign, highlighting, recognizing and celebrating the contribution that IT professionals are making during these unprecedented times. If you want to recognize colleagues at your work or elsewhere in BCS that are making a contribution to help with the impact of COVID-19, you can use the hashtag #VitalWorker on LinkedIn, Facebook, and Twitter. In case I don't get to mention it at the end, SIGIST will be running an online breakfast software testing networking morning on Wednesday, May the 20th. The focus will be on networking rather than speakers, and we'll be using Zoom breakout rooms to make it a bit more sociable than these large-scale webinars. If you're on the membership list, you'll get an invitation to that shortly. This event is in part to raise money for NHS charities. We've included a link in the event synopsis. If you didn't see it, it is on the screen now, and we're recommending a donation of £2. We won't be taking verbal questions during the speakers, as we have a lot of content to get through. We do have Slido set up. So if you put sli.do in your browser and then enter the code that's on the screen, 38951, you can put a question in at any point, and you can keep it open and vote on questions that other people ask as well, so that we get to the best ones first. This code will be shown again on some slides throughout the session in case you don't note it down now. Finally, selected questions that we don't get time to address will be answered on the members' emailing list after the event. And if you aren't a member, you can check out our Twitter account at SIGIST, and we'll post some of them there as well. So that was a super long intro. So I'm going to crack on and go to Khalil from the implementation team. Khalil, are you able to talk?
Yes, are you guys hearing me clearly?
Yes, very much so.
Excellent. Thank you so much for having me. Adam, it's really excited for me to be able to talk to your audience and share a little bit about what we're doing. So I am part of the COVID Safe Pass team. We spun out of MIT, and what we've put together is two technologies that form our solution. One is SafePass. That is the app that is downloaded to the user's cell phone. It gathers location data in the most privacy-preserving way. It's only able to collect longitude, latitude, and timestamps, and that information stays on the user's cell phone. It isn't shared to any central database. And then we have Safe Places. That is the web tool that the health authorities and contact tracers use to do their jobs. So the contact tracing process, when done manually, is quite laborious. It requires a patient who's just been tested positive and who may be experiencing a heightened state of emotions to remember all of their interactions and everywhere that they've been over the previous 14 to 28 days. And as you could imagine, that could be a difficult thing for them to do. We're prone to memory loss. And so what the app does, it provides a simple solution to this. You click a button, a simple export button on the app, which will gather the location data and put it together in a .json file, which the patient, if they choose to do so, simply shares with the contact tracer. The tracer will open the file and upload it to the Safe Places web tool, which will populate a map. And on that map, they're able to identify all of the locations that that patient has been over that period of time, 14, 28 days. And they could do their contact tracing process that way. They ask the patient for questions about their private residence or any other private residence that they may have visited over that period of time, and that may not be necessarily important to remain on that map, and they will go ahead and delete it to protect the privacy of the patient. So there's another layer here of privacy, ensuring the patient privacy, which is the redaction process. Once all of those private residences have been redacted, all that's left is or are the public locations that the patient visited or spent a significant amount of time. And from the Safe Places map, all individuals who have the app downloaded on their cell phone are then able to check for overlaps. They're not seeing the map. They only, once they hit that check for overlap button, they get that notification that says whether they have come into contact over time, the 14 to 28 days, with someone who subsequently tested positive for COVID-19. This was the deliberate design to ensure that people cannot use the timestamps and the map and maybe if they have access to cameras in an area, to go back and try to identify the individuals who tested positive. This is significant for low capacity countries where there's heavy stigma around people who tested positive. And so we took this step to minimize the risk of violence to them. So in a nutshell, that is our solution. It is the app and the web tool for contact tracing. So we've made significant progress over the last 6 weeks since we've launched. We are at various stages along the implementation process with a number of jurisdictions here in the US, but also globally. That number is close to 50. And we're working directly with the health authorities to adopt this. Now, our approach could either be bottom up or top down. It depends on the local context, and that changes from one jurisdiction to the next. In areas where there's low trust lower trust in the government. We work with influential groups on the ground to adopt the technology, and then they then sort of almost force the government to do it, because if they, the citizens, think it's valuable to them, then the government is likely to support that effort. In other places, it's a top-down approach where we first communicate with the local government. It could be a mayor, a governor, and they then engage their local Ministry of Health or the health departments, and we have that conversation. In some instances, it's been a hybrid approach, and so we approach first the government, and they pass it on to the citizens, and they say, we'll do this if our citizens would like it. So we've seen a mix of the three in our implementation approaches. So that's where we are, and that's our solution. And I'm happy to provide more information if you require.
Hey, Khalil, it would be great if you could tell us a little bit more about the successes you're having using an open source approach, and how you think that's going to contribute towards the success of this solution.
Yeah, I think that's a very important aspect of this, being open source. It provides this layer of transparency, I think, which is super critical at this point. For many, the governments that we're working with, they would like to have their country-specific app or city-specific app, and being open source allows them to take the technology and customize it in a way that best fits their needs, which is very, very important for us. I also think it's important for the community of developers who are working on contact tracing solutions to be open source, and so that we could create a product that communicates with each other. I think, it could be difficult as we go forward to have specific applications that is localized to a country or context that doesn't communicate outside of those boundaries. We live in a globalized world and people travel, and as you move across boundaries, I think it's critical to be able to have those apps communicate with each other, so that users can get notified if they come into contact with someone who's tested positively for the virus, and so they can take the appropriate action, whether that is self-quarantine or to contact the primary care provider.
Thanks. And I guess there's a lot of debate around GPS versus Bluetooth versus other protocols, etc. Speaking generally at the technical level, can you tell us more about the project's approach to different protocols?
Yeah, so currently we're using GPS. I think the whole world now knows about Apple and Google's effort around Bluetooth technology. And we're certainly hoping to work with them on that effort to incorporate it into our solution. We do know about the limitations of Bluetooth technology, especially with the iOS devices and its inability to work in the background. And that's the fix that Google and Apple are currently working on. I think they do have some strict requirements for developers and for solutions around contact tracing that may be a little bit problematic in its present form, though the process is constantly evolving and iterative. And I think, I hope at some point we will all come to a solution that allows third-party apps to utilize those APIs that they're developing.
Great. I think it's important to understand that the approach of the project is to collaborate with as many initiatives as possible, and not to try and compete with other contact tracing solutions.
Yeah, and this is important for areas where this is critical for economic development. This is a conversation that is ongoing beyond just the contact tracing capability of the solution. How does it fit into the broader workflow and framework that each city, state, country have developed to get their economies back online and to get people back to work? That is a very important discussion. Of course, it's one of those externalities that come as a result of public health. And if someone's not healthy, if they're not able to go to work, it's a bigger issue for the economy and productivity.
Sure, and you're working with a lot of other organisations as well. Are there, and I'm sure you need more help as a project, and we'll talk more about the help needed with testing later on. But is there any other kinds of volunteers or help the project is looking for?
So yeah, right now it's been incredible because we've been able to put together a massive resource group of people across organizations. So as you can see from the slide, we have MIT, we have PCG, Public Consulting Group, and we have Triple Blind and Upstatement, and a lot of the other apps or contact tracing solutions that were initially developed. We've sort of all come together under this umbrella to work, and I think that's important and a very critical first step, rather than working in isolation. So COVID Act Now, COVID Watch. They all started, independently, and we've sort of joined, our efforts. And then we're supported, of course, by the massive Ernst & Young, EY machinery, and their volunteers. And they've committed, an incredible number of their human resources, their management consultants, their development team. Susan, who we work with very closely, is a public health expert. And so it's an incredible team of people that we've put together to tackle this really important topic.
Great. Okay, so any other questions for Cleo, please add them to Slido. We're going to come back to those at the end. I see there's already one on there. And just a reminder, you can vote on questions as well. So I think, was there any other slides you wanted to go through, Cleo?
Yeah, that privacy remains at the core of our solution. And one of the reasons why we don't have a central server or databases to ensure that users have complete control over the data and who they share it with. And so there's no mandate that an individual, share the data with any government or health authority. And we try to remain as active as possible in all implementations. And when we do find out that, a jurisdiction somewhere around the world is using our solution in ways that are outside of our guiding principles, we do take very quick action to get in contact with them and to bring them into our discussions and to ensure that the right steps are being taken to protect the rights, the civil liberties of their citizens. That's very important for us. So privacy remains at the core of everything that we do.
Great. Okay. So now I'm going to show a demo because the first thing I did when I got in this project was to go and make sure that these claims are true. So for instance, what Khalil just said there about working with healthcare authorities, I can see it's very technically possible for a healthcare authority to have their access revoked from the central app. Now, hopefully this video will play effectively. So this is the launch screen of the app once you've installed it and given it the various permissions that you need. So there's a few things, there's a few pieces of informational functionality in there, such as finding out the latest news about COVID, potentially getting some advice, and this can all be customized by different health authorities as they roll out branded versions of this app, if that's what they wish to do. So a few other things you can do here. You can obviously disable your location sharing. You get permanent notification when you're sharing your location to make sure you know that it is in fact enabled, and don't forget. Within the app, you can select the health authority that you are subscribed to. You can also look at your exposure history. Now, I've got this set up at the moment looking at a test healthcare provider which doesn't have me near anything of concern. So I can see there that was last weekend when I was testing, and I have a green there because there is no concern point that's been near my location history. So that's simply a URL that the user has control of, so they can also offboard a healthcare authority themselves. And I can add in a test URL I'm using that has an infection point this just outside my house. And as soon as I add this I am going to get a notification that I may be at risk. Not that I have coronavirus, of course, but that I may be at risk. And it's important to realize all of this is happening locally on my phone. There's no data being sent to a server anywhere. There isn't any tracking of my location because I do not have coronavirus. So I have not shared my data. And I can see there that there was 10 minutes when I was possibly in contact with or near somebody who tested positive for coronavirus. So at this point, it's likely that I would be contacting my healthcare provider, the relevant NHS authority, and a contact tracer may manually ask me to share my location data. So at this point, a list of times and places that I have been would be shared through a mechanism of my choice. I've redacted some of the screen here, but you can see that via various applications, I could share that data. So maybe I email it to the individual contact tracer that's dealing with my case, which in this test example is of course myself. What I would then do is, as a contact tracer, I would then load that information into a web application that would be hosted in a decentralized manner at my public health authority. And the first thing I would do is redact this data, as Khalil was saying. So, and this isn't actually my location data. Getting good test data was obviously a huge challenge in a privacy-preserving way, and we'll come on to that immediately after this demo. But a contact tracer may identify, for instance, travel by car alone, that there's no need to include in the data, or they may identify my home address and decide that's not relevant to be shared. So there's a variety of tools here. There's a variety of tools here that allows that contact tracer to really decide what's important and just issue that data. Once the contact tracer has redacted the data, they're then enabled to join it with other data sets. Let me, the video me just finish redacting. So I save out the redacted data. And currently that's a file-based system, but it's moving to a database structure imminently. I'll go into my publishing tool where I can combine and publish different redacted time and location data files. This is important from a privacy perspective as well. Location data is very, very hard to anonymize. And if you have location data of just one person, it's even harder to anonymize. So this tool allows the aggregation of that data so that it is all in one big file, and then to export it with a name of an organization, an information URL, and to publish that out to consumers of the application. So only at this point would the application users in this jurisdiction get any kind of alert once this file has been published, and then the app several times a day will pull down the latest information. And I'm just going to show you the data structure that is exported at this point. The data leaving your phone is just longitude, latitude, and time at the moment. And as well, this data that's then provided outbound from health authorities is the same. It's slightly different data structure because it's points of concern, but essentially it is just, it doesn't contain names, phone numbers, any information like that. So I said before that we had a lot of difficulty getting hold of test data because in an open source environment, I didn't want to ask people to give me their data because that means, I don't know, does that mean I'm a data controller? Is that something I need to worry about from GDPR? So we had to start with my data and try and anonymize it. So at this point, hopefully going to flick over to Francesco, who's going to talk about how he produced some synthetic test data. I probably need to. Hey, Francesco, are you able to talk?
Hello.
Hello.
Can you guys hear me?
Yes.
Hi, Adam. So hi everyone, it's really a pleasure to be here. A very exciting time, regardless. So I'm Francesco, I'm the CEO of Primal, and I've been into, my background is in artificial intelligence, computer engineering, and I've been into this space for the last 15 years. And in the last two, playing with confidential data and secure data access at the intersection of machine learning and AI. So what we are building at Primal is something that, especially in this period, is extremely useful because there is more and more the need to collect data from individuals and extract insights for the main of the reasons that we know, unfortunately. And the problem of this aggregation is that most of the time they lead to confidential signals and personal identifiable information to be shared with governments or third parties, sometimes out of the consent of the individual, in fact. So what I want to talk about here, I don't have a lot of time, of course, but I will try to squeeze this in 5 minutes, is the current state of the data ecosystem when it comes to anonymization techniques. There are essentially three schools of thought when it comes to anonymization methodologies. The first is the one way we have seen being used in financial verticals as well as telcos. It's obfuscation and masking, which basically consists of having an individual, a human being, flagging what are the fields that are, they believe contain personal identifiable information, and just masking them out. Most of the time, this masking occurs with in a deterministic fashion. So this means that it's relatively straightforward to reverse that operation and re-identify these obfuscated records. Many other times with a bit more sophisticated techniques by integrating data sets publicly available or from other sources, it's again possible to narrow down the search and re-identify these obfuscated records. The second methodology is encryption, but not the encryption we're used to when we swipe our credit cards. It's another type of encryption. There are two techniques there that go under the name of homomorphic encryption and MPC, which stands for multi-party computation, using so-called Shamir scheme encryption schemes. I don't get the details, but basically it's an encryption scheme that allows one to encrypt data and perform computations on this data in encrypted state, which sounds amazing, and it is. We have been playing at Primal with this for a number of months, but these solutions are not scalable, not practical, especially from an industrial perspective. Most of the time, these secret keys are even bigger than the data that we want to protect or encrypt. So as you can understand, this is not really, a viable technology. The third school of thought about anonymization techniques is data synthesization, which we found to be the most scalable and secure of the three. I will try to squeeze it in another 2 minutes. Adam, if you can change the slide. So no matter what the technology that you are using, when you are anonymizing data or synthesizing data, there are two things that you have to pay attention to, which is the utility of the data and the security. And most of the time, you can't get both at the same time. So if you go for high utility data, most of the time, you're going for low security data as well. So high utility means that you want to preserve the statistical properties of the data, which means that you can share the data with a data scientist who might be training a machine learning model or performing some form of analytics on this data. And this means that in the synthetic data, you still find the same statistical properties that you would find if you got access to the original data. When you are in front of this data, the chances to leak some personal identifiable information or confidential signal is very high. So the best technology is the one that can provide you data, synthetic data with high utility and with high security at the same time. which prevents you from re-identification attacks, gives you a near perfect anonymization, and of course protect the individual record, while at the same time preserves the statistical properties so that you can perform your AI machine learning models on top. In the next slide, I'm going to show you I'm going to explain, in fact, what are the three methodologies that are currently used when it comes to data synthesization. From the most naive of all, the schema-based generation technique, it's a way to learn, sometimes even enforce in the data that you want to protect a certain schema. For example, the type, if there is an integer, a float, a char, a string, or whatever, you basically want to generate data that look like the original one, but semantically they do not preserve any internal property, and so this is just aesthetically similar. The second approach is a fancy one, the deep learning. We were using this stuff when it was not even called deep learning; it was called neural network. So let's speak about things with giving the right names to methods. So neural networks, there are two sub approaches there. The ones based on natural language processing approaches and generative models, or GAN, generative adversarial networks. So the first, the NLP, natural language processing network, basically allow one to consider a data frame or a data set, a huge string, and then they apply techniques that we are used to apply to text analytics in order to generate something, and so, or to learn the properties of that data. So if you take a data frame, you basically consider it as a string. In fact, you transform into a huge string. And what you usually do is you feeding a neural network with a window in which you have a number of characters, and you force the network to predict the next character. And so what happens is that at the end of the number of epochs that you're training the network, you have a neural network that, given a seed, starts generating data that resemble the original one. This stuff works when the data is small. For a few thousand records, to give you some numbers, this can take hours. But the biggest problem with this approach is that you're using a black box, and black boxes are very hard to control, and they would start learning things that you really don't want these neural networks to learn. So at some point, even before overfitting, these neural networks start learning so much of the original data that when you ask these networks to generate some synthetic data, they basically generate, they spill out secrets. And so they generate something that's not only similar, but sometimes it's really the same input, the same original data. And so we use, of course, one old professor of mine always said, when you're unsure about the two extremes, go in the middle, which is, in engineering jargon, is basically taking in hybrid solutions. And this revealed to be something that works. And this is exactly the technology that we are using at Primal. So we have a hybrid solution. We have, first of all, a quite sophisticated profiler that understands what your data looks like, and then it cherry picks the best method for that particular aspect of the data. And we do that in a differentially private mode, which I'm going to cut this to the minimum. It allows to add you a perturbation in the minimization of the function when you're optimizing a regression model or neural network. Basically apply a differential privacy methodology in order to kind of handicap the network a bit to the point that the network will never learn what the real data is. And so it will stop at the most similar version of the original data, keeping you safe on the side of, without disclosing the confidential signals that in fact you are protecting. I hope I did a decent job to squeeze this in 2 slides and 8 minutes. But of course, if you want to know more, don't hesitate to ask at the end of this webinar or get in contact with me via email. Yes.
Thank you.
Francesco@primal.io.
Thank you, Francesco. So, of course, the outcome of this was I was able to take my Google location history and take 1.7 million data points of my history. And you can see why I called Francesco to try and desensitize that data so I could make that available to the open source community so we could get some testing done. Because testing the end-to-end solution is not always possible when there's breaking changes going on different branches and things like that. And we really needed some of this data. So thanks for your help, Francesco.
Yeah, very welcome.
So now I will be handing over to Jonathan Wrights. Jonathan, I think this is you, but let me know if you don't get presentation rights.
Excellent. Okay, let me just share my deck. Hopefully you can hear me okay. So that was extremely exciting as far as what the possibilities are as for using AI and machine learning for synthetically generating test data. I'm now going to talk a little bit about testing the actual platform, and I'm going to run a few demos as well. I'll keep this nice and short so people can ask some questions. There is quite a few questions coming through on the Slido, so that's 38951. I will try and address some of those questions as I go along, as some of them are quite relevant. So I'm going to talk a little bit about the methodology approach that we did.
Hey, Jonathan, I don't think we've quite managed to transfer across the presenter right. So you sharing your screen?
I am indeed.
You've made me the presenter, actually.
Ah, okay. Let me try another one. Can you try sharing again, Jonathan? There we go.
Yeah, you should be able to see it now.
Fantastic.
Perfect. Okay, so partly what I was talking about is the approach that we took to testing this platform and this challenge. So I'm going to walk you through a few demos. I'm going to explain for those who are in the audience who maybe not have heard of the concept of digital twin. It may be referred to as kind of the shift right approach, so learning from the real world or from production. This isn't something new, so I wanted to kind of give a bit of backdrop about this. Literally 50 years ago, I think the 2 weeks ago, was the great example about obviously how they created a digital twin to help get the Apollo 13 back safely. But more recently, back in 2002, they've started applying this to the software development lifecycle, which is kind of where we're all involved. So I'm going to give you a bit of an example of where we've used this in the past and how this technology is applied to what we're doing now with the COVID SafePaths app. So the first aspect, as you see on the right-hand side here, we've got a smart city. So I'm going to refer back to a smart city project that I did, which kind of involved contact tracing back in 2015. So for the city of Copenhagen. So this was more for the purposes of becoming more carbon neutral, but it did have the similar challenges. And I know someone asked a question about, well, what happens if I'm traveling in a car? How do you remove that? And if I know Adam did a great demo, but one of his demo, whilst he was doing the demo, you'll see that there's a travel button, which is kind of anything that was over a certain speed. Now you may be asking, how do you identify this as a multimodal transportation? It could be transportation on the bus or, a train. So, how do you know that you've not come in and it's come into contact somebody and it was with a car? And I guess this is the real challenge because, especially when you're looking at data, how do you synthetically generate those different types of transportation? So, Google API will tell you things like buses and where they're supposed to be and the stops that they're going to be in, the GPX locations for those. We know what the train timetables should be. I know it doesn't happen here in the UK, but also we've got data like tubes. You get on a tube and you appear somewhere else in a GPS location. It's very sporadic and it can cause problems. So we have to be able to test these scenarios because, as one of the feedback questions was, well, how can you tell the difference? And obviously going through, especially during that interview period, you need to be able to understand the data set. So when we did this for the Smart City project in Copenhagen, we used a GPX logger, which obviously logs more frequently. So on average, if you just enable location data services on your Android phone, you're going to get 650 data points, which is pretty much every 5 minutes, which is hard to identify speed. Whereas the mobile app, which we developed for the city of Copenhagen, we were polling every 5-10 seconds. Obviously, a massive battery drain as well. But we were able to get data of people walking, at 3.4 miles an hour versus 12 miles an hour for if you're on a bike, and you can identify whether these people are walking or taking a different type of transportation. And we had a similar kind of challenge. We were looking at how do we synthetically generate it, because we needed historical data, and we were expecting to roll this out to 38,000 people who worked and lived in Copenhagen, which is obviously a much smaller scale than what we're trying to do here. But we still needed 5 billion historical transactions to be able to make it realistic, the data set that we could actually try all different paths through the system. And as you can see here, we got a number of phones. These are real devices, and we're overriding the GPS sensor to push the data in. And we're doing something very similar at the moment, where Haiti's the first location that's been rolled out. So we've got a whole stack of testers that are based in Italy who are using this technique of injecting locations and using real devices to start actually testing this product out in the real world. So, this is a kind of a quick example of something we've done in the past. I'm going to go on to prediction as well, because I think this could be potentially the next step. So this was a predictive crime platform that we're using. You can see it's the Washington, DC area, but we use this for secure government. And we took a lot of that data and we identified hotspots, which could be very similar to, to areas where, there's a lot more people, like Haiti. There's a lot more locations, public locations, in the main city center or tourist attractions, where obviously there's going to be more historical data, which is a lot more people are hanging around those kind of areas. So I think there's a lot more we can do, and these are extremely challenging times. So what I wanted to kind of talk about was, well, what was our approach to actually doing the testing for this? And I'm sure most of you have kind of come across the concept of model-based testing or cause and effect modeling. And this is very similar to kind of what we were talking about on the NLP side of things, is how we model out the different permutations through the application or system that we're actually testing. Now, we focus on the mobile app, whereas Adam's team's been more focused on the safe places aspect, which is the redaction tool, and be able to publish that GPS information. Whereas what we've done is we've created a digital twin of the application, and then what we've created out of the back of that is hundreds, about 10-15,000 different journeys that could potentially happen, and we push those directly into real phones. So I'm going to kind of give you an idea of what that model looks like. So this is a model that's been generated from the SafePaths mobile application, and the model will go through different routes. So you can see the model-based testing approach here applying. What we're also doing is we're using model-based testing data approaches as well to model the data. So that was kind of one of the challenges that we had initially, was before we were able to get this synthetically generated data, we obviously needed to have some kind of delta or some kind of base data set which we could use, which we were using our data, like Adam kind of said, which we exported from Google Takeout. So if you've used that platform, it allows you to export all your historical data. So that's all the locations that you've been around. So this took roughly about 5 hours to create, and that generated about 9,000 different routes through the system. And now we have a regression or automated pack which we run, which is roughly about 250 tests through every possibility. Now, we've used image-based technology for this type of testing, and the reason why is, as Adam would have shown you, is that you need to be able to interact with multiple applications. So you have to be able to, for instance, use an email client if you're going to, I know email is not secure, but you've got email clients, you've got, maybe you're saving it to a Google Drive or some other secure storage location, so you can share it with your interviewer or the person who's going through and looking at your data. So I'm not going to let this demo run all the way to the end, but I think one of the interesting parts of this demo is the kind of the sharing with the third party application. So this is kind of where you're exporting data, you know, and things like two-factor authentication. So part of getting your Google data in there, it would obviously come up and say, are you sure you want to import this data? We're sending a code to your phone. It needs to be able to go in there, get the code from the phone, and actually, you know, commit it. So, you know, we've had to have there's quite a few challenges that we've had, and being able to support multiple apps across the process. And we're going to obviously extend this out. We've got this for iOS and Android at the moment, and we're going to extend this to be, you know, the full contact across the SafePath app as well. So that's a bit of an idea of what we'd be doing. And a bit of a call to action before we kind of hand back to the team. But, you know, part of some of the skills that we're trying to kind of get at the moment, you know, there's a lot around localization testing. So, you know, if you've got the ability to be able to test a different language, you know, be able to log in, we're providing devices in the cloud at the moment. So you can literally log into any device. You can inject locations, you can change your localization information. So you can see on the screen, we've got Chinese there. And then you've got the ability to, we'll be able to provide you with the JSON files that you need to be able to load that data in. So at the bottom right, you can see Adam's example around importing synthetically generated data. We're looking at things like performance for the endpoints, security testing. But yeah, anything you can do to help would be a massive benefit to the whole team, really. So I've just added some slides. I know we're going to add some more slides at the end around how you can get in touch with the project. But yeah, check out the safepaths.mit.edu website and the covidsafepaths.org if you want to find out a little bit more. And you know, let's work together on and get involved. So I'm going to, with that, I'm going to hand back to.
Thanks, Jonathan. One question: Did you get licenses donated for any of these tools from any companies? Jonathan? Okay. Okay. So if I could just pull up the slides again, just give me 1 minute. So now, hopefully, Dermot, are you able to speak?
I can certainly speak. I don't know if you can hear me.
Excellent. Yes, I can hear you.
You can hear me. Good.
Yes, and hopefully the audience can hear us as well. So I guess you're the one that caught mine and Jonathan's interest when you first tweeted a little bit about this project. Can you tell us a little bit about how you got involved, first of all?
Yeah, so I'll give it a wind back a little bit. I live in Italy at the moment. I moved out to Italy about 18 months ago in a sort of Brexit-related move, which is a whole different story. But living out here, I guess I've been aware of the whole COVID situation a little bit earlier than people in the UK were, and just in terms of realizing the severity of it. I was, you know, talking to people back in the UK, and they were saying that, you know, they didn't think it was going to be such a big deal, etc. I work in the telecoms industry, and I've been working with customers out here. I've got people I work with in Milan, people I work with up in Verona as well, where, you know, the real sort of first serious outbreaks were. So, you know, and we went into sort of lockdown on 9th of March. So I was, you know, I was kind of very aware of that. And I started to get very stressed about the fact that the UK didn't seem to be taking it seriously, wasn't locking down early enough in my view, and was heading for a situation much like Italy. So I was worrying about that a lot. And then finally, once you know, the UK went into lockdown, I started to sort of stress about something else, which was, okay, so now everyone's locked down and we're kind of calming the spread of this disease. How do we actually sort of get out of this? And as I sort of thought about that, it became clear that contact tracing was going to be a kind of key part of, once you get the cases down low enough to be able to manage, that, you know, contact tracing would be a key part of how we get out of this, but that there's a kind of a need to do that at an unprecedented scale, which led me thinking, in my sort of background in technology about digital contact tracing, and don't know, and I still don't know whether it's going to be how much of a part of the solution it's going to be, but it's it may be a significant part of the solution to this whole thing, because we've got a long way ahead of us. Vaccines and treatments are who knows how far away. So then there was a paper published by some scientists in Oxford about digital contact tracing and the difference it could make, and I started kind of looking around and thinking maybe this is something I could get involved in. I think over the course of a few days I found about 15 different projects that were trying to do this, about half of them open source, the other half government projects of various sorts, and it sort of just all looked like a very fragmented space, and I couldn't really decide to kind of jump in with one of these things. But at some point in this process, I filled in the volunteer form at SafePaths, and actually they said, yeah, we don't need anyone doing testing. My background is in testing mostly, although I've done a whole bunch of different things in my career. I'm not, my coding skills are not really good enough to kind of contribute there. They basically said, yeah, we're not looking for testers. Maybe in a couple of weeks' time when we've sort of finished coding the app. I said, well, actually, I think you should be bringing in testers more or less immediately, but that kind of comment went unanswered. I said I thought the testers could add quite a lot of value early in the process before there was necessarily even any finished software to test, but that didn't really get picked up by anybody. But about 3 weeks ago, I think, having sort of forgotten about that, I got a message saying, yeah, the app is out on Android and we're looking for people to test it. So it was a Thursday evening. I downloaded the app, got it working on my phone, and the sort of brief was, yeah, just go through the screens and let us know if you see anything. So I sort of did that, but I was really frustrated because the app, as you've seen from the presentation earlier, the app doesn't really exist by itself. It exists within a whole ecosystem of these health authorities publishing data, and none of that framework existed yet, and that frustrated me because, I mean, as far as I was concerned, I couldn't actually test the function of the app at all. And asking around in the project, it's kind of known that we didn't really have all that set up, but nobody really thought it was a big deal yet, and I thought it was quite a big deal because, as far as I was concerned, I'd been asked to test something, and I couldn't test it yet because all the pieces weren't in place. So over the weekend, I wrote some tools that could, very basically simulate some of the parts of the infrastructure around it, and I kind of started digging into what I thought was not very well developed ideas about, what testing this actually really complicated product that's being deployed in an incredibly complicated situation. So I started offering some more ideas about that, and over the course of the sort of a few evenings working on this, I'd sort of worked myself into a position where I would sort of become de facto the person who was sort of running the show on testing for the project. So yeah, that's my story of how I got involved.
I think it's fair to say the project's probably attitude towards testing has probably changed with some of the pretty high value testing reports and defect reports we've been filing over the past couple of weeks, or at least I hope so.
Yeah, I think there's been a lot of change. When I came in, it was really, people talked about just QA, and the idea was make sure that the software we have written meets the spec. They basically wanted to give us a blueprint of all the screens, and us to make sure that we hit the right screens at the right points. And I think there just hadn't been brought in early enough people with real knowledge and understanding of what testing was. And my immediate response to that was, well, it's not just about whether we've delivered the spec. It's about testing whether that spec actually solves the problem. And I kind of started, trying to push some of these ideas, and actually it was like pushing at an open door. People were very, very receptive to that, and I think there has been a big change in terms of the understanding of what what good testers on a project can do in terms of the the insights we can bring, and how we can ultimately secure that the project actually delivering the value that everyone's got in mind and is set out to deliver. Great.
So is this the first time you've worked in an open source context, or have you worked on open source projects before?
No, I've not worked particularly on an open source project before, but I think even if I had, it might not have been much practice for this. The issue is not just it's being open source, but it's an entirely volunteer-based community combined with the urgency to deliver. And I think that's kind of quite a rare combination. I think a lot of open source projects, work with each person contributing the bits they want to when they want to, and that works well because there's no kind of immediate urgency and immediate need to deliver something in a very short space of time. So I think this project brings together those different factors in quite an unusual way, which creates some unique challenges.
And were you pleased with the response you got when you asked for help on social media?
Yes. Maybe if I just talk a little bit about how I got to that. About a week in to this, I'd be sort of basically spending every evening and my weekends on this, and there weren't really very many other people involved in testing. Some people had turned up and kind of worked through the screens on the app as they'd been asked to, and had kind of observed that it worked, and then they'd kind of gone away. There was one other person who I sort of considered quite a serious tester, but she really wanted to move into the UX side of things. Anyway, I was asked to organize this meeting between the product management team, the dev team, and the test team, just to kind of talk through blockers and what we needed from each other and so on. And because of time zones, a lot of the contributors are in the US, and not finding places in calendars, that ended up being at midnight my time. So we had this meeting, and this is the sort of first time I really got a sense of what was actually needed on the project. It was the first time I really got my understanding of the Safe Paths product, and there was this whole other product that was catering to healthcare authorities that I hadn't even looked at yet. And I went to sleep that night, and I woke up about 6 o'clock the next morning, and I just had this very, very clear view that that we didn't have the team that we needed to deliver, because it was effectively just me. And I'd by this time over the previous week, I'd recruited a couple of crowdsourced test companies that were going to be able to help out the app, but weren't going to be able to build the test strategies and planning and so on. So I had this real sense of needing help, and between about 6 o'clock and 8 o'clock that morning, I kind of pulled together this post and I put it on Twitter, and yeah, I was absolutely delighted by the response it got, which was actually two really interesting and different and both helpful responses. One was the one I'd kind of been hoping for, which was a bunch of people sharing it, a bunch of people saying, yeah, this looks good, this looks like important, this looks interesting. Absolutely, the testing community should get behind this, which was great. And then the other wave of response, I don't know anyone who's dug down into the sort of replies to the Twitter feed to find out quite other response, which initially was a bit of a sort of blow to me, but has ended up being incredibly useful as well, which was this huge wave of concern about the risk of mission creep and the risks to privacy and the consequences and all the potential difficulties with contact tracing. And actually that over the course of the kind of 24 hours that followed that, a whole bunch of people put a whole load of really thoughtful concerns and ideas and points into this about how we really need to worry about not just the good this product can do and how we make sure that it achieves that, but also the risks of harm that exist, and what we need to do to mitigate those. And it's not just about privacy, but kind of broader ethical concerns about the impact that this kind of technology can have. I'd love to have got more of those people actually onto the project, because I'd love them to be able to offer those insights a bit more directly. For the moment, they're choosing to kind of sit a bit further back, but I think that kind of criticism of this project is actually hugely valuable and helpful to make sure that we we achieve what we are setting out to achieve, and that we don't inadvertently have some other potentially costly and painful side effects.
Yeah, I think it's my reaction on Twitter as well was sort of divided between, I take your point, but you need to get involved in the project to help prove your point, and also there's really valuable insights coming out there that I know you've taken and started to build out on our Confluence. So every criticism we've had ethically on Twitter is forming part of our documentation and our thinking about how we try and prove what the solution does or doesn't do.
Mm-hmm. And I mean, the the other positive thing is actually to kind of pushing those kind of ideas out through the organization. There are plenty of people who've been involved from the project from the start who have absolutely been thinking through a whole load of those issues. Some of the challenges we've had with communication and documentation on the project, which we're kind of gradually getting through, have meant some of that's been a little bit obscured, and it's not been obvious always what thinking and worrying has been done before. But having kind of finding the right people and so on, it's clear that there has been a lot of deep thought about the risks and consequences of what we're doing. Though that's not something we can be complacent about. It's something we need to absolutely continue to think about.
And you touched on kind of the difficulties in mobilizing a volunteer testing team. What have the biggest challenges been?
It's huge ups and downs. A few days, maybe a couple of days after that that Twitter post, I had offers coming in left, right, and centre. People with large software testing companies saying, "Yeah, I've got some people who aren't doing anything next week. You can have them all." And I was thinking I was going to have 30, 40 full-time testers, and I was thinking, what on earth am I going to do with all these people? And then a few days later, I'm sort of looking around, and there's literally a handful of people who sort of put their hand up who are actually doing anything. So incredibly volatile from a sort of resourcing and planning perspective, and you just don't really know what's real and what's not. It makes it very hard to kind of plan based on that. The other challenge has actually been that the whole community runs in a very self-directed way. This is somewhere where you come, you figure out what's going on, you figure out how you can add value, and you do that. And I think that's the best way for a volunteer community to work, because for people to kind of want to stay involved, they've got to be really choosing what it is they work on rather than doing something because somebody else told them to. But I think some people have found that quite difficult. They turn up and they're like, I'm here and I want to volunteer. Please tell me what to do. That's again, if you don't really know if people are going to be able to have that many hours or they're going to stick around to spend a whole bunch of time in trying to give some people some really quite detailed instructions on exactly what to do is a huge time sink, especially if they don't, they find 2 days later they're not even there anymore anyway. So yeah, that people's need for that self-direction has been a bit of a challenge. And on the other side, the people who have come in, who've had a oriented themselves and figured out what to do and just got on with it, that's been absolutely amazing.
Yeah, it's been a very interesting experience for me as well. I mean, I've done a little bit of open source work before, but not at this scale, and as you said, not with this kind of urgency. So, in terms of the testing challenges that you had, I guess kind of the technical testing challenges, what did you start out with, and what challenges remain?
So when I joined, the biggest challenge by far was information, in the sense that there wasn't any really. Nobody really, the project had come together, very quickly and had grown very quickly. People who'd been around, for a few days before me were, veterans in some sense. Lots of information flying around, but very, very hard to locate. Everything was, undiscoverable Google Docs. There were a bunch of secret private Slack channels that nobody knew about, and you couldn't tell whether certain conversations were happening at all. So it was a mess, and the only people who really knew anything were all kind of too busy to too busy to help the people who didn't. So we've made a huge strides forwards. You mentioned Confluence. We've got a partnership with Atlassian, who's providing us with Confluence and Jira for free, and having that space to kind of organize content and lay things out has been huge. I'm very proud actually of where we got to in testing with that. All the other organizations are looking at what we've got and going, well, why haven't we done this yet? So we're a sort of beacon there in terms of what you can do for discoverability of information, and it's transformed versus what it was 3 weeks ago. Now the biggest challenge is, for me, the whole thing is it going to work, and what do we need to do to make it work? You can look at individual components, like Adam, you and I have both been working on the GPS logging right now recently, which just isn't as precise as we need it to be. And we know it can be more precise, but it's not there yet, the implementation within our application. But getting the algorithms right that are actually going to deliver the right user experience in the real world, worrying about dense urban environments. You've got people, living in tower blocks. What happens, if one of them's COVID positive, does everybody in the tower block get told that they need to self-isolate? And if you do have those kinds of false positives, then does that ultimately lead to people tiring of being told forever that they've been at risk of contact, even though they didn't even leave their apartment? And then people, obviously, you get the sort of crying wolf effect where people don't take the messages that actually matter seriously. So there's a lot of those challenges, and there's a bunch of work we can do thinking about those on a sort of theoretical basis. We also know there's a huge amount we're not going to learn until we actually get this out into the real world, which is where worrying about testing in production and how do we actually bring the information that we learn from early deployments of this stuff back into the product is absolutely key as well.
Thank you. And I guess the hardest bit of this is probably going to be balancing achieving a quality product with moving at pace in a public health emergency, right? Because we need to go live very, very soon for certain jurisdictions. And we have to get the right balance between getting the perfect solution and getting a solution with, that has the best UX and has the best location data we can get to. So how do you think we can balance that as a project?
So I think the key quality that people look for in this product is, does it have an impact? Does it reduce the spread of COVID in their community? And we only have that impact if the product ends up being widely deployed and high quality. So the impact and quality are sort of very much they're aligned with each other. They're not in conflict with each other. But there is there's a public health emergency going on right now. There are communities who could benefit from this app, even if it's not in its in its perfect state. We don't have Bluetooth yet, and we know that's a very desirable thing, particularly in certain certain types of geographic regions. It's one of the ways of dealing with the high urban density problems. But we also know we won't get this app right and get the algorithms right and so on unless we're actually using it in the real world. So it's about trying to work out how can you build something that will add some value now, get that out to the people that it adds some value to, make sure you understand where it is going to add value, what types of communities to target, and where it isn't ready yet, and then learn from them and keep making the product better, making it apply to a broader range of scenarios, making it better for the people that you've deployed with first of all, and making it applicable to the people that maybe it didn't apply to at the start. And if we keep iterating, then eventually we'll I hope have a product that is able to address most of the communities that need this in the world, and to help them at least to some level in combination with no doubt many other measures to control the spread of the disease and to enable people to return back to their normal lives.
Thanks, Dermot. So final question before we go on to the general Q&A. So what help do you need from the testing community? Jonathan mentioned localization. Are there any other skills, whether it's security testing or other, that you need help with?
Yes, I mean, my sort of, we need more people in general. As I said, there's been a lot of volunteers, a lot of enthusiasm, but actually quite low translation of that into people really making an active contribution. We really need people, whatever their specialism, who are able to come in and actually kind of set direction, work with a loose brief, and kind of create clarity. In terms of specific skills, there's quite a lot of working with some quite complex data sets. The app itself is quite simple, but the volume and complexity of data that fields into the real world is really where the complexity is. So people who are comfortable with kind of large data sets, data analysis. There's actually a lot of data science people in the project, some of whom are sort of more around in the epidemiology field, but we're managing to build some contacts with them and get them in to do some data analysis tasks in the testing space, which I think is going to be productive. But yeah, people who are comfortable with that. Automation, we have both a web app and a mobile app. At the moment, we have no automation in terms of testing, other than, well, Jonathan's done his sort of many paths tested, but there's other automation that we need. At the moment, there's actually quite a lot of change on the user interfaces, which means I'm quite glad we didn't invest in a load of quite tightly sort of targeted automation last week, but that will stabilize and we need to do that. Anybody who's got experience in testing in production, Jonathan's experience here and has been huge, invaluable, but anyone else who can contribute on that would be very helpful too. And as you mentioned, privacy and security, I mean, they go hand in hand, because if you don't get the security right, then you're probably not going to achieve the privacy. And privacy is absolutely key. This is, we keep referring to this as a privacy first project, and it's absolutely one of the founding principles we're trying to follow. And we need to make sure that the actual implementation matches the bold words that we're saying about this project, and that does require a lot of care and diligence from people who have expertise in those areas. So there's an awful lot of different skills that we're looking for. But yeah, anybody really who's got some time and the ability to kind of come in and set a direction for themselves in any of those areas would be hugely valuable to the project.
Fantastic. Thank you very much, Dermot. I think now we can move to some general Q&A. So I think probably between myself, Dermot, and Jonathan will be answering some of these questions. So let me go through them in order. The first one that's got not many people voting, but there is some order here. The first one, which I think was the first one was asked, was about second order interaction. So someone gets affected, then gets in contact with someone else, who then gets in contact with someone else. Does anybody, Dermot or Jonathan, does either of you have any suggestions on the answer to that?
I think I understand the answer to that, but and I think the answer is that we don't include that in our model. If you had a sort of a general, every data point affects another data point, which affects another data point, you'd very quickly get to the point where you'd have a very high number of false positives, and false positives are already a challenge on the project. I think a thing it's important to understand, if that sounds like a problematic position, is this technology will never never capture everybody, never identify every single transmission of the virus that happens. The crucial thing is that it has to catch enough of them that we can have a level of movement about within the community, whilst keeping the kind of R factor down below 1, so that the disease is stable or in decline rather than growing. And so there's a balance there, but a model I think that took anybody who's been in contact with the first person as therefore automatically infecting more people would just lead to too many false positives.
I think that's right. I think the application is about enabling health officials to work more quickly, to get better data and to respond to what's happening. It replaces like a time-consuming interview that's vulnerable to memory errors in the patient. It is not going to solve the problem without significant human intervention here. The next question is, do we have the name or number of the BCS paper that was mentioned earlier? I know BCS are issuing a press release, but I don't think the paper is available for circulation. The next question was about how hard this is for someone who's not tech savvy to use. Also, for people who are digitally excluded, apparently 60% of UK adults over 65 don't have a smartphone. Jonathan or Dermot, do you want to have a go at that?
So I could talk a bit to that. At the moment, the technology we have does require a smartphone, and we're trying to make it as easy to use as possible, so that people who are not very technically literate but may have a smartphone can use it. In terms of people who don't have a smartphone, there's I guess 3 things to say for that. First of all is we hope that they can benefit from the sort of overall community effect of reducing the spread of the disease, which will benefit everyone in the community, regardless of whether they they have this app themselves or not. The second point is, I know we are looking, and I'm not involved in these conversations, but I'm just aware of the threads happening within the conversation to look at what possible kind of very inexpensive solutions could be created in terms of creating a tech that could have a GPS tracker and run this app, but without being necessarily a fully featured smartphone that could be allowed to be distributed to people at a low cost in order to enable this. The other point is, and this is actually a key differentiator between a GPS-based technology and a Bluetooth-based technology, is that there's only actually a requirement for one of the, if you like, participants in this situation to have the smartphone. So the contact tracing conversation could happen with someone without a smartphone. That would have to be from their memory or from what other records they have. But again, it's possible for the health authority to actually then put GPS data that represents that person into their system, even if that didn't originally come from the app. And then that can still be shared with the whole community, so that people who do have smartphones will be able to observe where they may have crossed paths with that person. So it's a big difference between this and Bluetooth, which absolutely requires that both parties have a smartphone with the app installed. Actually, this can work just to some degree with people who don't have a smartphone.
Yeah, no, I think that's one of the things that's actually going on. I've been watching the code being committed overnight to develop the ability for contact tracers to manually enter locations they've been in that someone who's been infected gives them verbally. And yes. I think the other point on this is the prevalence of GPS versus Bluetooth. There's lots of phones out there that don't have modern low power Bluetooth, but do have GPS. I know it doesn't fully answer the original question, which is that there are lots of adults that don't own a smartphone. But inclusion in this process is a key factor in BCS's view on this, and I think it's a key priority for this project as well.
Yeah, just a couple of things on there as well. So we've been working obviously with crowd testing organizations as well, and one of the conversations I had with Dermot about demographics. So of course we're trying to represent realistic demographics for the locations that we roll out to. So we're able to look at obviously kind of the devices that are different per region, and connections using open signal and stuff. But also we're getting testers on board who hit that age range. I know there's a couple of people on today who are on the 65 plus area, and they would be a great source for crowd testing. So this is why we're reaching out to people of all ages, who with all different levels of experience. I think it's really relevant. And I know Patient 31, if you've not read about that already, is a great example of, obviously South Korea have kept the numbers really low, and that was manually entered. So they trace back the history of her going to church and turning up to hospital, and then log that data by memory. Of course we don't want to do that, but there is a proportion of people who aren't using smartphones, but there is also a portion which are. So I think it's balancing that out based on the different geographics and demographics within those regions.
Thanks, Jonathan. Let's take a look at the next question. And I think this is related to some of the comments we made there. So how would we respond to the argument that using low energy Bluetooth, i.e. BLE, is better than GPS in terms of being a privacy first approach? And this is something I've heard a lot. It's quite a contentious issue. Do either of you want to comment on that?
Well, I'm sure Dermot could say something. I know obviously with the NHS X app, which they've been testing, that uses BLE, and they've had a certain amount of accuracy. They was testing in the RAF base quite recently. But yeah, it is an interesting one because there's a lot of security concerns around Bluetooth as well. So, it's weighing up those areas. And obviously the conversation we had as well, Adam, with legal is, different countries have different policies, and therefore you may find that some countries are restricted for sharing GPS data. My question would really be about how Google managed to operate in those areas as well against those legislations, but there is going to be a lot of challenges down the road on this. Dermot?
Yes, I mean the location data is is obviously very sensitive, and you would have a more private solution if you didn't use any location data, no doubt, because there's a risk eliminated. Our concern is that if you don't have the location data, you actually lose a lot of efficacy of the solution. The Bluetooth, because it requires both phones to have the app installed, actually requires very, very high levels of penetration. In order to be effective, you get this n-squared effect, where if only 50% of people have the app installed, you end up with sort of 25% of the benefit, whereas the GPS based approach can give you a sort of a linear impact there. And this is, is a privacy first project founded on a bunch of thinking from MIT about how you can actually do the this privacy stuff in a in a secure, do the GPS data sharing in a secure and private way. Earlier, Adam showed these sort of plain text files with the longitude and latitude data. That is how we operate today, but there's at least two further iterations that we're looking at. We're not sure whether we'll do the first one or whether we'll jump straight to the second. There's some hashing you can do just to make those much harder to actually determine what that location data is. That's on top of the fact that it's already anonymized and jumbled up together. And there's a further technology. There's a paper from MIT on this, which we're looking at quite seriously deploying. It requires some more sophistication on the server side, but effectively a way for two systems to effectively determine whether they have an intersection between two sets of data without ever actually exposing each other's data at all. So, there's a lot more we can do to actually make the data that the health authorities have, even harder to access, and therefore much harder for that to ever be leaked. So our view is actually to be effective, the solution has to have GPS, and we're putting a huge amount of effort into how do we do that in a privacy protecting manner.
Yeah, I agree. I think there's a couple of other points. I think the context that GPS gives you is far greater than Bluetooth, but also it is more secure in that your phone isn't emitting a GPS signal and broadcasting it to other devices, whereas Bluetooth, people can essentially follow you around and track you and figure out your IDs without some very advanced algorithmic work. We've actually got someone on the GoToWebinar chat who's making a lot of suggestions about using magnetometer data. I have no idea what that is. Have either of you heard any discussion of magnetometer data, sorry, in the project? Okay, well, to that person, I've sent you my email address. If you want to reach out, then I'd be happy to share that information with the project. Just to go back to the questions on Slido, one of the next questions was, what support does a contact tracer get to know that an individual is traveling alone and therefore can be redacted? Is it all manual or is it supported by systems? So I'll take that one actually, because I'm working on the app that the contact tracers would use. So the contact tracers will receive training in using the app, of course, whether it's remote or face-to-face. In terms of knowing that an individual is traveling alone, that can't be known from GPS data. Presumably, that could only be possible by using Bluetooth data, which is one of the reasons that multiple angles and multiple different protocols needs to be used, because Bluetooth gives you proximity and GPS gives you location. So without those two pieces of data, I can't see how really useful information can be provided to the contact tracer on a large scale. In terms of, is it manual? There has to be a human in the loop in this process. This is about giving the information across to the contact tracer. So the next question was, how useful is this to a doctor who comes into contact with several tens of COVID patients a day? I'm assuming by doctor, that means contact tracer. I think going back to what we were talking about, this is all about automating that process and providing that public health official with more information so that they can do that process more effectively and more quickly.
I think the question may be about someone who's actually working as a doctor with COVID patients who's having lots of contact with them.
Okay.
I don't know, to which I'm not sure the app is particularly helpful. I hope that that doctor has the necessary PPE and is taking the appropriate precautions. Yeah, I mean, in terms of this app then providing protection for them when they're when they're not in a hospital setting, sorry, provide protection for anybody, but can provide an alert if they're at risk of catching the disease. It might do. Would that actually be any more than, I mean, they're already, I think, in their working environment highly at risk, and I would expect be taking a high level of precautions on an ongoing basis. So I'm not sure that people actively working with COVID patients like that are particularly a group that we're aiming to help with this app.
I suppose also there's an angle of how exactly the roles that have access to the data will come down to each individual healthcare authority. So whether it's an epidemiologist or a GP or someone working in a ward will vary by country. So the next question, if IT contact tracing needs a lot of subject participation, wouldn't standard public health tracing be more effective? How would contacts be isolated for infection control? I guess that comes back to, as we've been saying, this is all about automating that standard public health tracing. And I don't think we're qualified to answer on this call how patients would be isolated to control the infection. Yeah,
I mean, I'll just say that the project is working very closely with contact tracers. I think a big difference between this and some of the Bluetooth projects is this really is a technology that's about augmenting and accelerating the existing contact tracing processes, and we've been working closely with people who do that already to understand what they do right now and how we can improve that. The Bluetooth app's almost a completely independent solution that has no connection at all to the current contact tracing methods and and public health infrastructure. So there's a big difference there between the groups, and we're working closely with the people in public health in order to understand how we can help them to do what they're doing better. So this is not a substitute for contact tracing. This is a hopefully an improvement and optimization of the existing contact tracing processes.
Thanks, David. The next question is this linked with the NHSX/GCHQ app contact tracing system under development? And if so, how? So my understanding is no, but the offer is out there to NHSX to adapt and build on the frameworks that we've built. Jonathan, I believe you're probably closer to the NHS app. Can you confirm there's no link at the moment?
There's no link at the moment. They're in doing performance and load testing at the moment. It's aiming to be released to the public probably mid next month. Whereas obviously, we've launched the app in Haiti and getting the rollout to the US, and then the UK is further down on the list. So the NHSX app may be the first app that goes to market here. Obviously, GCHQ are working on that project based in Cheltenham. I know the guys there, they're obviously going about it in a slightly different approach than we are, and really that kind of highlights our privacy first led approach and transparency by having the open source project.
Thanks, Jonathan.
Yeah, I mean, with regards specifically to the UK, a rollout to the app, I think you can download it from the UK App Store today, but it's most useful when it's used in an environment where the local health authorities are engaged with the Safe Path project, have deployed safe places, and are putting their the infection data that they have out in a way that can be consumed. I think the UK is probably not a place that this is going to be rolled out very soon, because I think the NHS have their they have their plan, they have their strategy here, and we wouldn't make sense for us to roll this out without close engagement from the NHS, which I don't expect to happen particularly soon, unless it comes that we're having a lot of success with this approach elsewhere, and the NHS app is not having much success. And in that eventuality, then I think that might be when those conversations would start happening. Whereas we've got very active conversations in the US, and interestingly, in the US, this is happening at a very local and regional level rather than at a national level. So there's a lot of active conversations in the US, a lot of conversations with a lot of smaller and poorer countries that don't have a digital division for their health service. So they're looking to kind of to bring this in. But I'm not expecting this to be deployed in the UK particularly soon.
I think this plays actually really well into the next question on the list, which is, what is the planned lifespan of the app and the dismantling strategy after the pandemic finishes, i.e. a sunset clause? And I think this is really crucial. So as you saw in the demo I did earlier, the user of the application, the owner of the data, the owner of the phone makes an active decision to share the data with the public health authority. And it's only their last 14 days location that's shared at that point in time. So the lifespan of the app isn't so much relevant. The point is that users would stop sharing the data after the risk had passed, the pandemic has passed. Whereas with other solutions that are more centralized, where the apps continue to broadcast data, that's not going to necessarily be the case. Any comments on that, Dermot, Jonathan?
I think we might have lost Adam on that last area, so I think we can probably continue until he reconnects. I know he's in Barcelona at the moment, so different connections.
Do you hear me now,
so
Jonathan?
Yeah,
he's come back.
Sorry, I'm not sure what happened there. So I was just talking about the answer to the planned lifespan of the app question and the dismantling strategy. A key point here is that the user is the one that that shares the data with the health authority, and once the need has gone, why would they do that? I figured I lost audio again then. Jonathan, can you try and manage the last 3 questions?
Yeah, I'll jump on the last couple. So we've only got 2 more. The penultimate one was what population take-up of the tracing app is needed for the overall solution to work. And we've got a lot of shared material. I think the IET put some information about potential rates based on adoption. That's one of the things that we're working on quite closely at the moment, is to understand engagement rates, because obviously it's privacy first and privacy by design. So we're not able to get, you're not sharing any information from your phone. So we're able to take that information from obviously things like App Store and other location information like Google Play to understand how people are using the app, and also, of course, for them publishing and sharing that information. So, Dermot, did you have anything you wanted to add on that one?
No, I've sort of seen numbers that people have said in the past. Ramesh, who's the kind of project lead at MIT, has I think talked about sort of 50-60% numbers as for it to work. I think that, but the other thing I think in terms of, if you define it working in terms of keeping the R below 1, I think it's really important to understand is this is just one piece of a very large and complicated jigsaw, and we hope this has as much effect as possible, but there's going to be a whole range of other measures that are going to be necessary, I think, in order to contain this epidemic effectively. So assessing the app in isolation is probably not it's probably not the right way to think about this. It's just one of a number of different measures that will hopefully do their bit in helping.
Yeah, so the numbers which Dermot just referred to with the 60% came from a study by Oxford University. Australians are looking at about 40% at the moment, which have downloaded, about 10 million people, and they're starting to see some success. So, anything between 40 and 60, I think, is the number that we're kind of hoping for. And finally, the last question there is this application linked to a symptoms tracking app? If not, should it be? Debbie, what's your views on that?
I don't have a strong view on that right now. No, I don't know exactly what's going on there. I've seen various sort of ideas floating around, but at the moment we're really trying to keep our development quite focused on you know, a certain set of things that we absolutely need to do for the core function of the app to be focused. There may well be partnership conversations going on there, but I don't have any more detail. Should it be? Yeah, I think there's probably value in linking those functions together, both in terms of sort of driving uptake, and I can see a whole bunch of other sort of benefits that you get from that. But I'm not aware of anything specific there. I'm sure someone is thinking about it though.
Absolutely, and you know, there's a lot of participation, especially in the US, with healthcare, and digital healthcare is obviously a very big thing. So people like Cerner in the US have these kind of apps as well. So you know, the future integrations, and also how the data is used, because I think this is the challenge really, is if we're going to learn anything from it, the more data that we can, publicly available data that we can start looking at, will be really help us down that journey. So I thank so much, David, for coming on and taking the time out. Francesco unfortunately had to go, but you know, I know there's some great resources to link out there. So David, you're on LinkedIn. What's the easiest way to get directly in touch with you?
Yeah, definitely my LinkedIn, also my email, francesco@primal.io, or Francesco Gadaleta on LinkedIn. I will ask Adam if he can share my contact somewhere else.
Excellent.
Yeah, likewise, you can reach me on LinkedIn. If you want to volunteer for the project, there's a volunteer sign up page. I don't know if we've linked to that somewhere, have we?
It might be on the screen, or it might have gone the way of my audio.
Yeah, so if you go to the covidsafepath.org, or you know, the MIT link which we had before, and then go to join us, that will take you straight to the Google Docs. But there is a bit of a backlog, so if you want to speed that process up, then just reach out to Adam. He's got his Twitter there, Adam Leon Smith, all one word, or Adam at dragonfly.co. You know, and he'll help your onboarding process, or reach out to one of us who've taken part. So thanks again to everybody who's taken the time out. I know we're running slightly slightly late, but thanks again. And you know, we're looking for anybody to help and, you know, add some value to this and make a real difference.
Thank you very much, everyone.